Hello students, today we will study about the third method, that is the cross multiplication method, right? This is the topic of chapter number 3, standard 10, pair of linear equations in two variables, right? So before this we have studied the elimination method and substitution method. So this is the third arithmetic method to solve the pair the linear equations in two variables. Okay, so let's suppose there are two linear equations. First one is a1x plus b1y plus c1 is equals to 0, and a2x plus b2y plus c2 is equals to 0. Okay, so first of all we will understand by taking these two standard form of linear equations. Then after we will see one example. Okay, so to find out the solution by cross multiplication method, we have to consider here only the coefficients and constant. Okay, so before we start, you have to first of all check that your constant term is to the left hand side of the equation, and the right hand side of the equation there must be 0. Okay, if in the question there is a constant term in the right hand side, then you have to take it to the left hand side, and then after you have to start to calculate the sum. Okay, so here is the method. First of all you have to take x, then in the denominator of x you have to write down the coefficients and constant. So how to write it? Okay, so for that, suppose there is an x is a variable, then you have to cover this portion of x. Then what are the coefficients and constant remain? There is b1, b2, c1, c2. So these four constants you have to write down here: b1, b2, c1, c2. Right? Okay. In the same way, here is this equals to now the second variable, that is y. So in the denominator of the y, what we have to write down is same way as we have covered the x, here we have to cover the y variable. Okay, so now what will the remain? a1, a2, c1, c2. But you have to start to write down from this c1, c2, and then after you have to write a1, a2. Okay, then again this equals to, now both the variables are here, then we have to take here 1 upon in the denominator. Now we have to cover this constant c1, c2. So what will remain with us is a1, a2, b1, b2, right? So this is the same thing, a1, a2, b1, b2 we have to write in the denominator of 1. Okay, so here this is the simple method. You can remember it that as you have taken here b1, b2, c1, c2, then in the denominator of y you have to start from this c1, c2, right? So the first one is c1, c2. Now you do not have to consider y, then only the a1, a2 is remain. Okay, and here also as we have end here with a1, a2, you have to start with a1, a2, and as we do not have to consider the constant term, you have to write down here b1, b2. Okay, so in this way you can form this, right? Now cross multiplication means we have to multiply this constant with this constant, right? That is why this method is called the cross multiplication method. So now we will multiply this b1 with c2, b1, c2 in the denominator of x, b1, c2, and b2 multiplied with c1. So b2, c1 we get here, right? And both we have to subtract. So what we will get here is x upon b1, c2 minus c1, b2. In the same way here in the denominator of y, we have to multiply this c1, a2 minus this a1, c2. In the same way here 1 upon, we have to multiply a1, b2 and a2, b1 or b1, a2. But we have to put here subtraction sign, right? Okay, as these three values are equal, now we will compare this portion with this. and then after we will compare this portion with this portion. Okay, so from this we will get the value of variable x. So by comparing this portion with this, what we will get? X is equals to, now by comparing this with equal to this term will goes to the numerator and the denominator remains the same. So we will get x is equals to this b1 c2 minus c1 b2 in the denominator a1 b2 minus b1 a2. In the same way, by comparing this with this, what we will get? This portion denominator goes to the numerator. So y is equals to c1 a2 minus a1 c2, denominator remains the same, a1 b2 minus b1 a2. So in both the way, in both x and y, the denominator remains the same. Okay, so let's understand this by an example. So let's suppose two equations we have here is 2x plus y is equals to 5 and 3x plus 2y is equals to 8. As I have said earlier, if your constant term is to the right hand side, first of all take it to the left hand side. So what we will get? 2x plus y minus 5 is equals to 0. 3x plus 2y minus 8 is equals to 0. By doing this, now we can start our calculation. So x upon, now we do not have to consider this constant. So what we will get? 1, 2 minus 5 minus 8, right? b1, b2, c1, c2 is equals to y upon, now we have to cover this y. First of all, we have to write down these constants, minus 5 minus 8, then after a1, a2, that is 2, 3. Now 1 upon, cover this portion, we will get 2 upon 3 and 2, 3 and 1, 2, 2, 3 and 1, 2. See here, this one and this one remains same, this one and this one remains same. Okay, now we will multiply this. So x upon 1 into minus 8 minus 5 into 2 is equals to, in the same way, minus 5 into 3 minus 8 into 2. And here we will get 2 into 2 minus 1 into 3. Okay, so now simplifying by this, we will get x upon minus 8, this will be minus minus plus and 5 to the 10, so plus 10. In the same way, y upon 5, 3, but 5 is minus, that is why we will get minus 15. This again minus minus plus and 8 to the 60. The same way, 2 to the 4 and 3 ones are 3. Okay, so now here we will get x upon 2 is equals to y upon 16 minus 15, that is 1, and here 1 upon 1. Okay, so as now we have to compare this one with this and compare this one with this. So by comparing x by 2 by 1 upon 1, we will get x upon 2 is equals to, this 1 upon 1 is 1. So by taking this 2 to the right hand side, it will go in the multiplication with 1. So we will get x is equals to 2. The same way, by comparing y upon 1 with 1 upon 1, it is 1, and that is why by taking this 1 to here, we will get y is equals to 1. So this is the solution for both the pair of linear equations x is equals to 2 and y is equals to 1. Okay, so this is all about the cross multiplication method for the solution of pair of linear equations in two variables. Okay, thank you.